Okay, right, so describe experiments to investigate electrolysis using inert electrodes, aqueous solutions of dilute sulfuric acid. Now, the most common place to see the dilute sulfuric acid is actually in the Hoffman voltammeter. Okay, and now the key point here is that it is actually dilute, okay? So that's important when we're thinking about it, okay? And you need to predict the product. So let's look at what the reactions actually are. So the sulfuric acid breaks down to give us 2 hydrogen ions and a sulfate ion, and the water breaks down to give us a hydrogen ion and a hydroxide ion. Okay, so what happens at the cathode? So cations go to the cathode, so that's pretty straightforward. Okay, and at the anode, okay, we got our sulfate ion and we got our hydroxide ion. Now, fair enough, it's actually dilute, okay? So because it's dilutes, the most concentrated one around it is going to be the hydroxide ion. And also, just in case there's any doubt, the sulfate is the weakest of the reducing agents, so it's going to be the hydroxide that gets preferentially discharged. Okay, so what are the reactions then? Right, so our hydroxide ion gives us water, oxygen gas, and 4 electrons, and our hydrogen plus 2 electrons to give us hydrogen gas. So what actually happens is if you balance the ionic equations for electrons, you can see that this actually happens. We get 2 moles of this, so we end up having 2 H2 and an O2, because we can multiply this whole equation here by 2, so that's 4H2 plus 4E minus to give you 2H2 gas. Okay, so that means we're going to have at one electrode, the anode, we're going to have 2 moles of hydrogen, or sorry, the cathode, and then at the anode we're going to have 1 mole of oxygen. So you see you have a 2:1 ratio produced at the top of the Hoffman voltammeter. Okay, right, so okay, that's because it's dilute sulfuric acid, so you don't need to know the difference between concentrated and dilute. Even if you did, it's quite straightforward. And the products are water and hydrogen, so basically Hoffman voltammeter is splitting up of water.